here we've got EVE-NG, and we're going to connect to our NetEdit device here. So we've deployed NetEdit on EVE-NG. We're connecting to our out-of-band management network, and you can see all of our switches also have a leg in the out-of-band management network, as they should. So we're using DHCP to give out IP addresses to our two switches here. In a future video, we'll configure everything here in the access layer, but for right now, we're just going to focus on the two switches in the core layer. So I've already got some basic configuration on them, things like the SSH config and the HTTPS config. Oh, that's not HTTPS, HTTPS. And so you need to turn these on and allow read and write access to the HTTPS REST API and configure a password that NetEdit can use to drive the CLI of the devices. That's already been done, so we're going to discover those devices and push configuration to them. So we're going to be configuring, like I mentioned, the interswitch link here, which is a set of 2, 4, or 8 links. This is used for control plane synchronization and management plane synchronization. So this is going to allow our two switches to ultimately become one switch here. And the keep alives are going to be point-to-point routed links. So it's going to be a /30. It's going to send hello packets back and forth between the two switches, so that if the primary switch goes down, the secondary can detect that and modify itself according to the situation. Essential for this. If you've ever worked with Cisco VPC, that's a Nexus technology, it's going to be kind of similar to that. But more on that in a deeper dive. First, we need to go over to NetEdit because we need to first discover our devices. So to do that, we need to go to Actions, and we need to click Discover Devices. We've got our subnets already configured to save time, and our lab credentials already put in. So we'll just go ahead and use those, and then we're going to go and click Add to add the seed addresses. So what I do is just add both switches here. So the first one being .77, and then the second one being .68. We're going to go ahead and just use these two IPs that are already configured on these switches. We're going to select both and check mark both of these here, and then we can go ahead and discover these devices. So as you can see here, we are discovering our devices are starting to populate here, and once we have a status of green check there, basically we're going to be able to go ahead and configure the rest of these device configurations. So what we need to do next is go ahead and click on these check marks, and we're going to go to Action, and then we're going to click Edit Configuration. So here you can see the configuration editor in NetEdit. We have both devices in the column here. You can choose between and toggle between which one you're looking at the configuration for, but the key thing with NetEdit is what's called multi-edit. So with multi-edit, we can use variables to configure our devices. So if you look at hostname, you click on it, it just says hostname, but when you actually use the right click, you can actually independently set those parameters across all the switches in the configuration plan. So we're going to use that feature to quickly configure and deploy the rest of what we need for VSX to work properly. Let's go ahead and put this in. So first thing we need to do is create our Keep Alive VRF. So we're going to put in VRF. We're going to put in the KA for Keep Alive. And then we're going to create our link. So interface 113, just according to how I had it set up in EVE-NG. And then we're going to put in a no shutdown. We're going to add a description for Keep Alive. And we're going to put in the VRF attach and set that to Keep Alive, and then we're going to add, we're going to make this a routed port with the routing command, and then we're going to go ahead and put the IP address 10.0.0.1, and this is going to be for the first switch here. Obviously that mask is totally incorrect. Let's go ahead and fix that. It's going to be a /30. Alright, and now with the variables, we'll just go ahead and modify switch 2 to be the .2 that we need it to be. So now that we have our Keep Alive link created with our VRF to isolate that so that only keep alives are going through that VRF. We're going to create our lag. So interface lag 100 is going to be for our inner switch link, and it's just a trunk with all allowed VLANs. So we'll name that description, and we'll call that ISL. Then we'll say no routing because we want to put VLANs on this, and then no shutdown. And then we're going to put the two commands that we need to create VLAN trunk. In this case, it's VLAN trunk. We're going to put a native VLAN of 1, and then VLAN trunk allowed all. So super simple, nothing to it. We're going to also specify LACP mode active for this as a best practice here. And then, so the next thing we need to do is attach that to our interfaces, and let's go ahead and do that with the lag 100 command, and that's all we need to do on the physical interface itself. Now, it's pretty easy to work with port channels in comparison to Cisco for reasons that we're not going to get into here. But as you can see, if you've worked with Cisco, it's a lot simpler to deploy link aggregation here. So let's go ahead and now create the actual VSX configuration we need. So we'll put in the global command of VSX, and we'll define the system MAC. And this is predefined, something I came up with already, but that is basically a shared MAC address that both switches will use for forwarding traffic at layer 2. And we'll go ahead and put in the inner switch link command to tell it to use the correct lag that we've already set up. And then we're going to go ahead and put our roles in. So role primary, that's going to be for the first switch, but then on the secondary, we're going to put that as secondary. And then we're going to put our keep alive information in there. So keep alive, peer, and I always start with the first one. So our peer is actually going to be .2 in the perspective of the first switch. Well, our source is going to be 1, and that's using that VRF we created earlier. So now we can go ahead and edit this for our secondary switch and just flip-flop those IP addresses. Let's go ahead and do that here as well. And that should give us what we need to successfully deploy VSF. So next you're going to go up and click validate, and NetEdit is going to go through and just validate all the syntax of everything you just put in, which has passed. So we're good there. Now we can go to return to the plan, and let's just pretend we're in a change window. And so we need to add some change management data here. So we're going to call this deploy ISL and keep alive for VSX, and we'll just call it basic VSX configurations. And then we're going to go ahead and just approve, say I approved it, and that the change is in progress. So we're going to save that. And now with device validation and conformance testing pass, we go ahead and deploy this solution out to the devices. So we've already predefined in the settings a set of change validation commands for VSX, and you can see them here. So it's going to automatically run all of the enabled command sets that are here. Let's go to return to plan, and we're going to deploy this again. So as you can see, this makes human error during change windows very much reduced, right? There's still the potential for errors, as we saw, but it's significantly reduced, and giving that one-click rollback to remove that configuration is a really good feature. Now we can see that everything is actually correct. So we're in sync. Our peer is established, and the keep alive is established. Our role is primary. So let's just double check the LACP aggregates. You can see that those lags are created. Let's go ahead and click OK, and now we can go ahead and commit this change. Since we know that it was 100% successful, we can commit the change and lock it in. So next, the last thing we need to do is edit the plan attributes, and then we'll go ahead and click complete. We'll save that. So our change window is successfully completed, and we have deployed Aruba's VSX at a basic level. Next, we're going to set up our downstream links and our MLAGs for our access layer switch. We're going to discover our access layer switch and turn up our port for our PC so that our devices can reach gateways that we'll also configure in the core layer. Thank you for viewing.